I would like to go over how to work section 8.3, problem number 6. It's the last homework problem in that section. This hypothesis test says a candy company makes 5 different colors of candies. Find the sample proportion of candies that are green. Use that result to test the claim that 16% of the company's candies are green. Use the data table below, the p-value method, and a significance level of 0.05. So if you click on this icon right here, it pops up a data table. And what we'll do is basically count the number of candies that we have. And then we need to see how many of them are green. So if you count down this way, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, we have 14 candies in this yellow candies. And what I'm going to do is basically just make a block. I have 5 rows of 14. So 5 times 14 is going to give me 70 candies represented there, 70, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I better make sure I did that right. Yep, 11, 12, 13, 14. I'm counting another 14 candies, so it looks like we have 84 candies represented in that table. So that's our N. That's how many candies we have total. And we know that there are 15 of them that are green. So that's X. And then N is going to be 84 candies. So we're going to select our null and alternative hypothesis. I'm going to write down some of that information that we just found out. So our N is going to be 84. Our X, the number of green candies, should be 15. We'll erase some of that writing that I don't think we're going to need anymore. Okay, so our null hypothesis always has the equal sign in it. And so we have a few choices there with the null hypothesis with an equal sign in it. Since we're testing the claim that 16% of the company's candies are green, the alternative is that 16% are not green. So this is going to be the choice here. The next question says, what is the test statistic? So we're going to run a hypothesis test to be able to answer that question. We already decided the null and the alternative. It's a two-tailed test. So step 2 would be to draw your distribution. This is a one prop Z test in your TI-83 or 84 calculator. It's two-tailed, so our alpha is 0.05. We have 2 tails, so we'll cut that in half. So we have 0.025 in the upper tail and 0.025 in the lower tail. And we could actually find those critical values if we wanted to. This particular problem is saying you use the p-value method, which we could do. But just for consistency's sake, to see how it all fits together, I'm going to go ahead and use inverse normal. And we should get negative 1.96 and positive 1.96 as critical values. So we're going to reject the null if our Z is less than 1.96 or greater than 1.96, or if our p-value is less than 0.05. Let's go ahead and do our one prop Z test. To see if I can share my calculator with you. So we're going to go to Stat, Tests, one prop z-test for proportions, hypothesis test for proportions. I already had a different problem worked out in here. The null hypothesis, the claimed value is this 0.16. Our n is 15 green candies. Or sorry, our x is 15 green candies out of a total of n 84 candies. Our alternative is selected, and so we will calculate. Our z, let's write down the things from the calculator so we don't have to come back. Okay, so we wrote down the information out of the calculator from that one prop z-test. So we'll go ahead and fill in the rest of our homework here. So it's asking for our z test statistic, so the difference between the data and the test statistic, or sorry, the data and the claimed value. So we'll fill that in here. Our z was 0.46 rounded to 2 decimal places. Our p-value is the second portion of our second portion that came out of our calculator. So it's rounded to 3 decimal places. It's going to be 0.642. What is the conclusion of the null hypothesis? Well, if we look at the p-value and compare that to alpha, our p-value is not less than alpha, which meant that our test statistic would fall somewhere in this unshaded region closer to 0. Because you can see the z-score 0.46 is in close to 0. It's not out here in the beyond 1.96 or negative 1.96 in the tails. So our p-value is actually much larger than alpha. And so we are going to fail to reject. Remember, if the p is high compared to alpha, the null will fly, meaning we keep it and we fail to reject it. So we will fail to reject because the p-value is greater than the significance level alpha. Anytime we fail to reject, that means there's not sufficient evidence. So what happens is for our claim, let's go back and see if we can take a look here. What happens is that our claim, we fail to reject. So in other words, we are keeping that. We don't have enough evidence to warrant rejecting it. So we're going to select that conclusion. There's not sufficient evidence to warrant rejection of the claim that 16% of the company's candies are green. If you have questions about other homework problems, please let me know.